ductility in a structure. The lateral load resisting on structural system can be of the following four types.
RC moment resting frame, then RC moment resting frame with unreinforced masonry infills. So these four types of structures are called generally RC structures. There are number of RC structures which might be precast concrete structure, pre-stressed concrete structure. Now if you are speaking in terms of ductility, here we insist only this four types of construction. One is RC moment resting frame, next one RC moment resting frame with unreinforced masonry wall. So that is brick, hollow block structure which is built in between the column, and RC moment resting frame with RC structural wall. This is called a shear wall. This is highlighted in 13920/2016. This code is primarily to make the structure from brittle mode to ductile mode. How to make a structure to perform in a ductile manner. Design and detailing both are discussed here for reinforced concrete structure subjected to seismic force. So if you want to make your structure ductile and earthquake resistant structure, you have to follow this code book in accordance with IS 456-2000. That is generally used for plain and reinforced cement concrete structures. Now, what is the first case? This is called a frame. You have column and beam along horizontal direction, and vertical direction you have column. And you can see infills. What are these infills? They are called brick infills. If this kind of infill structure is provided, you can follow this IS 13920 to make it ductile, and it can be with infill or without infill. What do you mean by without infill is some structures might use glass. The Bangalore highway, so NS 47, you can see number of tall structure which only glassings are provided in the perimeter of the building. Without infill, glass should not be considered as a load resisting element, and RC moment resting frame with RC structural wall. So this is the example for ordinary moment resting frame with infill. And if you are adding the shear wall, this is a wall. What do you mean by shear wall? This is a concrete wall which has the reinforcement from bottom to top. You can see this is a foundation. The rods will stretch from the foundation to the topmost story of the structure. So you have the connectivity from ground to the top of the structure. So this is called shear wall. Reinforced concrete wall has been constructed. This is the last type, RC structural wall. Purely you can use RC structural wall, or you can use RC frame with the structural wall. This is combination of RC frame with structural wall, and purely you can construct RC structural wall. Okay. Now, design strategy. You have to follow a strategy in order to make the building as ductile. This can be provided only for RC construction, that is reinforced concrete construction. What are the other type of construction available? For precast RC structure. What do you mean by precast? See this picture. These are all prefabricated element. They are fabricated in the industry, and you can see this is a beam. A beam is being fabricated, and you can see a corbel. This is known as corbel. In a column you will be having this kind of corbels, and they just erect these beams in that corbel. So the dimensions are predetermined. You know the column will be for 4 meter height, and where you need to place the beam will be having that corbel. Everything is being dimensioned and it is being fabricated. So you can make this kind of element, and just you can erect these things in the column. This is called precast RC structures. Another type of precast structure, the reinforcement which is projecting from the beam. In these spikes, what they will do is the slab will be precasted, and they will just place the slab rod will be connecting to the spikes, and they will weld. So they will cast only the joint. You can see these are the joint which they will be making, and only small amount of in situ concrete work will be done. So this concept which we are looking is only for RC monolithic structure which is constructed in the site itself, not for these kind of structure. You can use for precast and or pre-stressed concrete. Only they are designed to provide similar level of ductility. Wherever possible, you have to follow the design and construction of reinforced concrete shall be governed by IS 456 only. Throughout India, if you are designing or constructing a concrete structure, primarily it has to follow what code? IS 456. Along with that, you have to use IS 13920. So both the codes are applicable. Note that when you read the two code books, it will not merge with each other. Whatever is said in IS 456, they adhere that. They say that it is applicable. Over the above, you have to use IS 13920. If you are referring number of code books, no code books will clash each other. So they adhere with the adjacent code books. They give the guideline and pathway to construct the structure. Except those elements participating in lateral force resisting system. Does column resist the earthquake force? Yes. If you are not providing column, only by using brickwork you construct, what happens when earthquake comes? Your structure will crush and it will fall. Yes or no? So column is a member which resists the earthquake. That is primary. And beam. Without beam, you imagine, remove all the beams, only slab is available. What happens when earthquake comes? Total slab will seat on the floor. Yes or no? So beam are the secondary part of lateral load resisting system. So these are being indicated here. So the modification and provision of this standard for those elements participating in lateral force resisting system. They are beams and columns. If you want to make ductile resisting structure, what should be your grade of concrete? Start from M20. M15 grade is being used in construction. Have you seen number of construction which are built only using M15? They will put 1 part of cement, 2 part of sand, 4 part of coarse aggregate. They are following it now. This is a practice. But if you want to make your structure as earthquake resistant, what grade you should use? M20, 20 and more than that, M25 as the minimum grade. Maximum grade you can go above whatever is required as per your requirement. See, do you think metro concrete is same grade what you build in your house? Metro concrete is high performance concrete. All the concrete are not same. Concrete has different variety. If you see in red you have different red color, that is cherry red, dark red. In green you have different green. Like that in concrete you have different concrete. High performance concrete, high strength concrete, then lightweight concrete, foam concrete. You know what is concrete? The mixture of cement, sand, fine aggregate and coarse aggregate. Now you have these different concrete. As of now in your curriculum you need to know there are some different modes of concrete. What you lay in metro is high performance concrete. You cannot see large aggregate. Have you seen any large aggregate during the construction? You cannot see, but you can see here 20 mm aggregate will be available. That is the difference. In high performance concrete, they use additional 2 or 3 ingredients. You only add 4 ingredients. What are they? Cement, sand, fine aggregate, coarse aggregate for making a concrete. But for high performance concrete, at least additional 2 materials are being used. 2 additional ingredients are being used. So they might be, one is fly ash and one chemical admixture they will be using. So with this, these are the structure of making high performance concrete. Okay. What is the use of high performance concrete is, you see the pillar of the metro, without painting they are being able to withstand the environmental temperature. Yes or no? All the buildings are painted, but the metro is 24/7 into 365 days in winter or in rain, but they are not painting. Why? Don't you question the metro people? Why? Because they are high performance. High performance doesn't need any plastering. Here you do plastering. After making the brickwork you do plastering, then you do the First primary coat of whitewash, then 2 coats of paint. But why can't they do for metro? The normal students and normal people can ask, but you as a civil engineer, you should know that is high performance concrete. Your house can also be constructed by high performance concrete. You no need to make the plastering, you no need to make painting. Whatever you are finishing, it will be in a shaped manner. How they make is in concrete structure. If you are doing MTech or ME in concrete structure, there you have a separate unit or module called high performance concrete. In MTech structures, if you are learning in concrete structure, you have one topic how to make high performance concrete. You would have wondered how to make concrete in a seashore. More than 15-meter height in the seismic zone 3, 4 and 5. How many zones are there? Zone 2, 3, 4, 5. There are 4 zones. Total India is being splitted into 4 zones. Only 3 zones up to 15-meter height or more than 15-meter height should be using M20 or M25 grade concrete. But less than that, what is less than that? Zone 2. What are zone 2? Mysore is zone 2. Bangalore is zone 2. Mandya is zone 2. Along these plains, you have zone 2. In those zone 2, if you are constructing less than 15-meter height, what is 15-meter height? How many floors? 5 meter. 3 meters to 3.5, maximum 3 meters to 3.5. So if you divide by 15 by 3.5, 5. Up to 4 to 5 floors, it is not required. But if you are going more than 4 to 5 floors, definitely your building should be minimum of M20 to M25 grade. If you are building ground floor plus first floor, then they are saying that but not less than required as per IS 456 on exposure condition. If you are looking into exposure condition, in IS 456-2000 you have this table 5. Under what environment, what grade of concrete should be used? See, there is first environment called mild. Minimum grade of plain cement concrete they have not given, and for moderate, severe, very severe and extreme. These are the places according to the environment. If you are building in extreme case, the extreme case might be you are building near the seashore, harbor. You are building the structure for chemical industry, leather industry, textile industry. If you are building concrete structures for them, they use harsh chemical. If the phenol is being manufactured, they use harsh chemical, yes or no? They have to manufacture in some place. There might be spilling of these chemicals, the concrete should not deteriorate. Those are extreme case. If you are constructing the industry, you have to take the condition as what? Extreme. And the grade of concrete should be what? Minimum M25. All concrete structure are not same. If you are building house is different. If you are building industry and atomic power structure is different. Atomic power structure have different code book. For plain concrete, for reinforced concrete, if you are making RCC building, then your grade should be what? Minimum itself M40. So that they are saying in this code book that, but not less than required by IS 456. If they are indicating minimum 40, now in IS 13920, they indicate minimum 20 and 25. Which grade you will follow? M40. Now you should not say that, sir, in IS 13920 they say that minimum M20 to 25 is enough. But you should use your brain. They are giving minimum. So when you compare M25 and M40, M40 should be taken as minimum. Now you have to proceed with that. Now the steel reinforcement has to be used. Now concrete is over. You understand that while using M40 grade concrete, what is the cement ratio? 0.4. When you see the site, practicality is there. They put water as like sambar they are mixing in the rice. They will put more water and they will mix it, and then how you eat, like the same way they will make. More number of sambar will be there and rice will be dipped. The same way they will do practically. They will use more water. Why? Because no need of compaction. Who is going to compact? Pour the concrete like water, that's all. You will be having a box, pour the concrete like water, then it will flow. Baddest concrete, poorest concrete. After 6 months, it will be known how your structure performs. After 6 months, the client will call you, sir, I am one of your client, can you remember me? They will call. See, my clients have not called me till now. I have made a 2000 liter of water tank. For G plus 1 story, I have installed 2000 liter of water tank in a slab. 2000 liter of water tank is how many kg? 2 tons of weight. What is the live load you are taking for design in a slab? 1.5 kilonewton. 1.5 kilonewton is how many kg? 150 kg. You are designing the slab for 150 kg, but when you place the water tank, you will be having cylindrical water tank, yes or no? In top of all structures you see, you have a black color cylindrical water tank, which will be 1000 liter or 2000 liter. When you install 2000 liter of water tank, what is the weight acting on a slab? 2000 kg. But live load what you take is what? 150 kg. How many times of increase? 12 to 13 times of increase. See, the slab is not the slab, you will design the slab and you assume, you design by StatPro, ETAPS, everything you do, but the many of the designers I have seen, they will not include the weight of the water tank. When you place water tank in your roof, does it going to impact your slab or not? Definitely it will impact. Today you will not know, but the client will call you after some years. If you are just installing 1000 liter of water tank, they will call you. After some days, there will be crack in the roof. They don't know for what purpose the crack comes. When you go to inspection, you will know. So they think that different reason, but the reason is this one. When you are installing the roof, live load is less, but different load will be more. You will be having different things in the roof, so the load will be more. See, why I am saying these things are, when you are really a civil engineer, if you are looking the world into a civil engineering, you have different things to learn day by day. Whatever is given in the code book, you should know to apply in the field also. The laborers will not do. The laborers are like kids. Imagine that, how we are thinking you as a kid. Why we are not scolding you? We think you are a kid. Whatever you do, we assume as a kid and let it be. Same thing what you should also do. To whom? Laborers. You should treat them as your kids. They will be naughty, notorious. If you say to do their work, they will not do. ಇದು ಮಾಡಿ ಇದನ್ನ ಮುಗಿಸ್ಬೇಕು ಇವತ್ತಂದ್ರೆ ಸರ್ ಇಲ್ಲಿ ಕೆಲಸ ಇದೆ ಸರ್ ಇದು ಮಾಡಬೇಕು ಸರ್ ಅಂತಾನೆ ಹೇಳ್ತಾರೆ. They will not follow your words. You have to train them. And when you say water cement ratio should be 0.5, when you are there, they will use 0.5 of water cement ratio. Soon if you go there, they will put more water and compact, and when you come after it, the work will be over. And if you are using M20 grade concrete, what is the water cement ratio? 0.55. You try. Now you are doing number of projects. I don't know how many projects are done in concrete oriented project. You try with 0.55 of water cement ratio, mix the concrete, you know the workability of concrete. It will not flow. Okay, you learn from that. Steel reinforcement used shall be of grade 415 or less. According to earthquake resistant structure, you should not use grade of steel more than Fe 415. If you are using mild steel, it is good for earthquake resistant structure. If you are using Fe 550 and 500 grade, then what point should be noted? The elongation should be more than 14.5%. Whatever grade you use, you can use. But the elongation should be what? 14.5. If you have 100 centimeter of rod, how much it should elongate? 114.5, it should elongate. If it is not elongating before breaking, you should not use that steel for what purpose? Earthquake resistant purpose. In RC framed building, lintel beam preferably not be integrated to column to avoid short column effect. This is a lintel beam. This lintel beam, you are merging column from the bottom to the top of the roof. But here they say that if you are measuring the height, if you are having a window, do you have lintel beam here? Yes. This beam is running through. Then your column height should be what? Not from the floor to the roof. Your column height should be floor to the lintel is one column, and from lintel to the roof is second column. Why you divide the column for first floor and second floor? Why? Because you have a beam. If you have beam like this, you see one column and second column. You see two columns in this. Practically speaking, actually speaking, this is not one column, this is two column. Short column attracts more shear force. That is why there are many failures around the window. If you have done that, then the code says that what you should do. Okay, if you are considering it as a single column, then by using any software, it might be ETABS or StatPro, what analysis you should do? When you integrate, they shall be included in the analytical model for structural analysis. When you are making as a model, you should be making into two column and do the analysis. Provision of standard shall be adopted in all lateral load resisting system of RC structure located in 3, 4 and 5. This standard is optional for zone 2. IS 13920 is optional only for zone 2 in India. You do not need to follow whatever cities have zone 2. Where it is applicable and where it is not applicable, you should know. If you are in a city of zone 5, definitely you have to follow and strictly adhere this. RC regular moment resting frame building shall have planar frames oriented along two principal plan directions of building. What are the irregularities is, if you are looking a building in a plan, if you see this kind of shapes, these dimension should be followed. In no case A by L, this is A and this is L, this should not be greater than 0.15. So these ratios should be followed. Irregularities listed in IS 1893 shall be avoided. If you are having setbacks like this, your architect is saying, no, I need the building in this shape only, and client is also adhering with that. He is also most interested with that. Then if you want to, then structural engineer want to construct a structure in the sense, what he has to do is, he has to do irregularities with what analysis? Non-linear analysis shall be performed. So, in the BE syllabus, you do linear analysis. There are two types of behavior for each and every material. One is linear behavior and another one is non-linear behavior. What do you mean by linear behavior is, if you give a force to a member, take this as a column. If you apply a force to column, remove the force, the column will come to its original place. This is called linear behavior, and if you add 1 kg, 1 mm of deflection will be there. 2 kg, 3 kg like that, you can constantly increase force, deflection will be constantly equal. This is called linear behavior. Linear is a straight line. Non-linear is, if you are giving 1 kg load, 10 mm deflection will be there. This behavior is known as what? Non-linear. If you give 5 kg, it will go to 15 mm of deflection. It will be not linear in the sense, then it is called non-linear analysis. If you are not doing this kind of building, your dimensions are not coming according to IS 1893, then what you have to do? You have to do what analysis? Non-linear analysis has to be done. And if you are doing that, you will be not having any loss of property during earthquake. What is your aim? If any earthquake comes to my building, it should not collapse. That is your primary aim. It has to perform like that, then you have to follow this thing. This is not any Z-Boomba. If you are constructing building, putting Z-Boomba and saying, my building should not destroy or crush during an earthquake. You cannot say that. If you follow that, definitely your building will perform well. Most of the structures around you and your structure will perform definitely well during the earthquake.